Good evening, student. I'm audible to you. Hello. Good evening, student. I'm audible to you. If I'm audible, you can type yes in the comment box. Okay. So what question given to you? Question is given to you. Find the 1 plus x whole to the power 6 and 1 minus x whole to the power 6, and then evaluate the root 2 plus 1 whole to the power 6 and root 2 minus 1 whole to the power 6. Okay. Ansha, I'm audible to you. If I'm audible, you can type yes in the comment box. Okay. The first term is 1 plus x whole to the power 6, and this is x minus 1 whole to the power 6. Okay, and we have to expand it. Okay, there is a property called binomial expansion. We know that. Okay, here we get. Okay, we know that what is the formula of a plus b whole to the power n. Here we get. If we talk about the rth term, so rth term will be tr plus 1. What is the formula of tr plus 1 term? We know that in binomial expansion, that tr plus 1 term is given by the formula ncr into a to the power n minus r into b to the power r. This is the formula of general term in binomial expansion. So we're not talking about the first term. And we also know that if the power is n, then we get n plus 1 terms. So here the power is 6, and here the power is 6. So from these two individuals, we get 7 and 7 terms. Now talking about first part, that is x plus 1 whole to the power 6. So what is the first term? What we can say that if you want to find the first term, in the place of r put 0. So we can say t1 is equal to what? 60 into what is the value of a here? The value of a here is x on comparing by these two forms. Okay, so we can say this is nothing but a to the power 6. Sorry for that, not a to the power 6. X to the power 6. X to the power 6. And what is the b here? B is 1, and any power of 1 will also give us 1. So this is 60 into x to the power 6. Now, how can we get the second term? So what is the t2? In place of r, put 1. So in place of r, if you put 1, so we get the second term will be 61 into x to the power n minus r, means 6 minus 1 will be 5, and 1 to the power take any number will always give us 1. Now talking about third part, that is third term. How can we get the third term? In place of r, put we can say 2. So if we put in place of r we put 2, we get nc2 into x to the power 4 into 1 to the power 2. Then again it is equal to 1. So there's no need to write again 1, because if you multiply any number by 1, we get the same number. So there's no need to written here 1 to the power 2. Okay, so let's remove it. Now talking about next part, t4. How can we get the fourth term? Answer is clear to you. What I'm explaining, this everything is clear to you now till that part. Okay, so now how can we get the fourth term? And sorry for this is not n, this is 6, because in the place of value of n is given as 6. Now how we get the fourth term? If we place in the place of r, we put r is equal to 3. So we get here 63 into x to the power 6 minus 3, that is 3, into 1 to the power 3, that is again 1. How can we get the fifth term? In place of r put 4, so we get 64 into x to the power 4 into 1 to the power 1 square, that is again 1. So there's no need writing 1 square. Okay, now talking about the last two terms. How can we get the six terms? If we put in place of r, if we put 5 in place of r, so we can say this is nothing but 65 into x to the power 6 minus 5, that is nothing but 1, and 1 to the power 5, and again this is equal to 1. Now talking about last part, that is 66. How can we 7 term? We put r in place of r we put 6, so we get 66 into x to the power 0 and 1 to the power 6. Again this is nothing but 66. Now talking about the next part, there's two binomial expansion. If we talk about second part, let's write it here in left hand side. Sorry for it. What is the next term? The next term is x minus 1 whole to the power 6. Okay. Again, how can we get the first term here? We get t1. If in the general formula, we can say here a is equal to what? Here a is equal to, if we compare to a plus b whole to the power n this form, we can say here a is equal to 6 x and b is equal to minus 1. So how can we get the first term? If in place of r we put 0, so we get here n60, not nc0, 60 into a to the power n minus r, means x to the power 6 minus r, that is nothing but x to the power 6, and minus 1 to the power 0 again will give us plus 1. Talking about second part, so how can we get the second term? Okay, let me use another pen, that is more better, otherwise we will confuse the first and second part. So how we get the second term? We can say that if in place of r we put r is equal to 1, so we get 61 into x to the power 5 into minus 1 to the power 1. We get here minus 1. So can you see that? Into minus 1. Now talking about third term. How can we do the third term? Again, in place of r put 2. So we can say this is nothing but 62 into x to the power n minus r, means x to the power 4 and minus 1 ka square will give us plus 1. Talking about fourth part, how can we answer? Everything is clear to know what I'm explaining. Every thing is clear. If it is clear, please respond. You can type yes in the comment box. Okay, so how can we get the fourth term? In place of r put 3, so we get 63 into x to the power n minus r, means which is nothing but x to the power 3 into minus 1 to the power 3. That is giving us minus 1. Talking about the fourth part, sorry, for the fifth term, how can we fifth term? In place of r put 4. So okay, so if in place of r we put r is equal to 4, we get what? 64 into x to the power 2 into minus 1 to the power minus 1 to the power 4, because here b to the power r and here r is equal to 4. So again, minus 1 to the power 4 will give us plus 1. So we multiply by the 1. Talking about the sixth part, again, sixth term. How can we get the sixth term? If in place of r we put here r is equal to 5, so we get 65 into x to the power 6 minus 5, that is 1, and minus 1 to the power 5, that is nothing but minus 1. So this is the sixth term. Talking about the seventh term, how can you get the seventh term? We get the seventh term if in place of r we put r is equal to 6, so we get 66 into x to the power 6 minus 6, that is 0, into minus 1 to the power 6, and minus 1 to the power 6 will give us plus 6 plus 1. Okay, so if we notice, okay, let me separate this part. Let me draw the separation here. This is the expansion of first term and this is the expansion of second term. I'm writing it so we can easily judge what is the pattern here. So we can say that if we see the pattern, the quotient of the sum is same. Means if this is T1, if this is T1 and the T1 and T1 are same. If it's the second term, so if this is 61 x to the power 5, the second term is 61 into x to the power 5 into minus 1. So can we say that if we add these two terms, the second term will get cancelled out. Similarly, we can say that here the fourth term is negative of the next expansion, so fourth term will get cancelled out. And similarly, we can say that here the sixth term will also get cancelled out, because the term which the sixth term which we get from the expansion of first term, that is x plus 1 whole to the power 6, and the term which we get from the expansion of x minus 1 whole to the power 6, these are the negative of each other. Okay, so this will also get cancelled out, and the term which remain is nothing but, we can say that 2 times. Okay, these are the term 2 times present, so we can say this is nothing but 2 times, just a second, 2 times 66, sorry, for 60 into x to the power 6. This is 0, not 6. Let me write clearly here. Plus ka 2 times the third term, that is nothing but 62 into x to the power 4, and then we can say that plus ka 2 times the fifth term, that is nothing but 64 into x to the power this is square, sorry for that, actually here's the calculation error. This is not 4, because x to the power n minus r, so 6 minus 2 will be 6 minus 4 will be 2, not 4. So this is 2 times 64 x square. Talking about the next part, that is the last term, twice of this seventh term, that is nothing but 2 times 66. Can you see it? Now add all these terms. So what is the value of NC0? By the formula we know that NC1 is equal to n, NC0 is equal to 1, or NCn is also equal to 1. So by the basic property of binomial theorem, we can say that this is the first term, the coefficient of first term, that is 60. Discriminatiness 1. So this is 2 into 1 into x to the power 6. That is nothing but 2 into x to the power 6. Plus ka, what is the value of 62? We can say this is nothing but 2 into, how can we use, we can use the formula of NCR. So answer, can you tell what is the formula of NCR? Let me write next page. The formula of NCR is nothing but n factorial divided by r factorial into n minus r factorial. This is the formula of NCR. So if you that formula here, we can say that, just a second, this is nothing but 2 times 62. 2 times 62 means 6 factorial minus 2 factorial into 4 factorial into x to the power 4. And the next term is 2 times 64. Again, this is nothing but 2 into 6 factorial divided by 4 factorial into 2 factorial into x square. And if we talk about the last term is twice of 66, and we know that the formula of NCN is 1, so 60 n can be written as 1. Now let's simplify this term. We can write this 6 factorial as 6 into 5 into 4 factorial. From this 4 factorial, this 4 factorial term will get cancelled out, and again we can say this 6 factorial is nothing but 6 into 5 into 4 factorial. So from this 4 factorial, this 4 factorial will get cancelled out, and we can say that 2 factorial is nothing but 2 into 1. From this 2 will get cancelled out, and from this 2 will get cancelled out. Let's add all the term, or rearrange all the term properly. So we can say this is nothing but the first term is 2 times x to the power 6, and this is 6 into 5, 30 into x to the power 4. This is 30 into x to the power 4. The next term which we are getting here is nothing but 30 times x square, and the last term is 2. And then think this is the expansion of the term binomial term given. And what is saying, after finding the expansion, find the value of this term. Which term? Let me write it here. I'm writing the below it. Okay, after finding the expansion of this term, we have to find the value of root 2 plus 1 whole to the power 6 and root 2 minus 1 whole to the power 6. Okay. So it is asking for to find the value of root 2 plus 1 whole to the power 6 and plus ka root 2 minus 1 whole to the power 6. So if we compare the formula which we have derived, can compare that this is nothing but the formula which we expanded. This is nothing but x plus 1 whole to the power 6 plus ka x minus 1 whole to the power 6. So can we say that in place of x we are getting root 2, and in place of 1, it is also present 1. So if we expand, so we can simply, we have already expanded this form where the value of x is root 2. So in place of x put root 2. So we can say that the value of this term is nothing but 2 times root 2 whole to the power 6, root 2 whole to the power 6 plus 30 times root 2 whole to the power 4 plus 30 times, this is 30 not 36, it appears like 36 but this is 30, okay, plus 30 times root 2 square and plus ka 2. So if we add all these terms, we get 2 times, what is the root to the power 6? What is the value of root to the power 6? We can say that what is the square of root 2? The square of root 2 is 2. So we can say that root to the power 6 will be nothing but 2 into 2 into 2. That is nothing but 8. So this is 2 into 8. Okay, next part. This is 30 into root to the power 4 will give us 4. So 30 into 4. Talking about next part. This is 30 into root 2 square. This is nothing but 2 and plus 2. So if we add all these terms, we get 2 times 8 16, 3 times 4 120, 3 times 2 60 and plus ka 2. So if we add all these terms, this is nothing but 18 plus ka 180, and that is nothing but 198. That is the final answer to this question. Hello, sir, I'm audible to you. Answer, your voice is not reachable to me. If I'm audible, you can type yes in the comment box. Okay, thank you for joining.